Hello friends, in this video we will discuss about one more problem given in GATE 2019 for ECE stream and this in signals and systems, and this problem is related to least square approximation to FIR filter design. Okay, the problem goes like this. We have to approximate a 7 length sequence h of n with a 3 length sequence g of n. So the samples of h of n are given as here. Okay, and we have to evaluate g of n such that this cost function, let us call that to be j, which is to be minimized, and finally we are asked to evaluate this term, so 10 g of minus 1 plus g of 1. Okay, so let us use Parseval relation to solve this problem. Okay, so according to Parseval relation, so if you remember the signals and systems class, the Parseval relation is for a signal x of n is defined like this. So summation n equal to minus infinity to infinity modulus of x of n whole square should be equal to 1 by 2 pi times integral minus pi to pi modulus of x of e power j omega whole square by using this d omega. Okay, so by using this Parseval relation property, so the given cost function j given by this can be equated to this term. By expanding this term, what do we get? So we get 7 terms. Okay, so by expanding the summation we get 7 terms because our h of n has only 7 elements from h of 3 to h of, so from h of minus 3 to h of 3. And what is the question? So question is first if we have to evaluate the signal g of n. Okay, so how do we get g of n and how many elements g of n has? So according to the problem, g of n has 3 elements, and those 3 elements are nothing but g of minus 1, g of 0 and g of 1. So all other values are nothing but zeros. Okay, so all other values are zeros because our g of n is only 3 sample signal. So now question is we have to evaluate these samples g of minus 1, g of 0 and g of 1 such that the cost function j is minimized. So how do we minimize this cost function? We differentiate that with respect to the unknown variable. So first unknown variable for us is g of minus 1. So if you differentiate that with respect to g of minus 1, so what will happen? You will get all other values are zeros because these terms does not contain g of 1. Only this term, only this fellow alone has g of minus 1 term, and hence if you differentiate with respect to minus 1 and equate it to 0, you will get 2 times h of minus 1 minus g of minus 1, and again you have to differentiate this term inside the bracket, and hence you will get minus 1 here. And if we equate it to 0, so definitely we can see that g of minus 1 is nothing but h of minus 1, which is equal to minus 3. So we have got g of minus 1, and similarly proceeding in the same fashion we can get the values of g of 0 to be equal to h of 0, which is equal to 4. How do we get this? You differentiate this again the cost function j with g of 0 and then equate it to 0, you will get this result. Similarly, how do you get g of 1 to be h of 1, which is equal to 3, and then how do you get this? You differentiate this cost function with respect to g of 1 and equate it to 0. You will get g of 1 to be equal to h of 1, which is equal to 3. And in this way you can evaluate g of 1, and you are asked to evaluate 10 times g of minus 1 multiplied with g of 1, so which turns out to be minus 27. Hopefully you have understood this problem. Thank you.